Hi, and welcome to Allen High School Pre-AP Chemistry. We're in the midst of our discussion of stoichiometry. Now we're going to add another conversion factor, but this is something you've seen before. What we're going to do is talk about going from mass of a liquid to volume of a liquid and back again, and that's density. And we can always write density as a conversion factor. For example, the density of water, actually like something like 3 degrees Celsius, but we just assume it holds true unless told otherwise, is 1 gram equal to 1 milliliter. So we can add that to our arsenal of conversion factors here. So step 1 is to write our reaction. So we have bromine, Br2, is reacting with calcium iodide. And this is a, get a new one, kick the other to the curb. Remember our analogies? So we'd get calcium bromide and then pour iodine. Iodine's diatomic, never left alone, really. Okay? So I've got 400 grams of calcium iodide. You notice I'm putting this right underneath the calcium iodide. And it says how many liters of bromine. Now, here's the deal. Liquid bromine. I don't get to use that lovely 22.4 liters equal to 1 mole. Don't get to use it this time. We have to take an extra step. So, what we're going to do, map it out. We're going to get mass to moles. Okay, I'm going to make this a little longer because it's going to be a few steps the other way. Then we're going to take moles to moles. And then we want to go grams, or moles to mass, excuse me. Now I want you to notice something here. Let me write the conversion factor this way. 3.12 grams is equal to 1 milliliter. You can write that next to this. That might help you. 3.12 grams per milliliter. So before I can get to liters, I have to get to milliliters, and then I can get to liters. So this is many, many steps. Mass to moles, moles to moles, moles to mass, mass to milliliters, and then to liters. Okay? So let's start this puppy. Get this going. And it's a very, very long one. I'm going to try to just write a little smaller so I don't run out of space. Now, I have 400 grams, mass to moles. Use molar mass. So I want to get rid of grams and go to moles. 1 mole is 293.88 grams of calcium iodide. Moles of calcium iodide. Now I'm here. I want to go moles to moles. Moles to moles, use the mole ratio. There's 1 mole of calcium iodide for every 1 mole of bromine. So you can label above it and below it if you like that better. It kind of streamlines it a little bit. Now I'm here. Now I want to go moles to mass. So moles to mass, use molar mass. For Br2, it's 159.8. Don't forget your diatomics for 1 mole. Never hurts to do a quick double check that your units cancel, and they do. Now, I have grams, and I want to go to volume. Well, the only conversion I have are grams to milliliters. Now, once I have milliliters, I can get to liters pretty easy because 1 milliliter is 1 times 10 to the 3rd liters. Okay? My density gives me that conversion. If you write it as an equality, I think it's a little easier to see. 3.12 grams is 1 milliliter. Wow, if you crank out all of that, you get 0.0697 liters. Or excuse me, 1, because we like you to go to the given, and we assume conversion factors are exact numbers, even though they're not. But you have to have something to kind of start with as an assumption. So there we go. So that's how we integrate density into the picture. So let's take a look at another one and see how we're doing there. I don't know if I'll do both of these. This integrates STP with this, and then this is a volume to mass problem. So I'm going to start with this first one. Mercury is added to excess. You're going to love those words. Excess silver nitrate. Tells us I make mercury 1 nitrate. Mercury 1 nitrate's really a wacky little ion. Some of you may say, wow, why didn't I reduce that to a 1-to-1? But the mercury ion, mercury 1 ion, always has to come in pairs. And that leaves silver all by itself. So I'll need a 2 there, and a 2 there, and a 2 there. Okay? So we have 46.7 milliliters. We also know that its density is 13.6 grams, equal to 1 milliliter. This is in excess, which means we can ignore it. Okay? Now it asks us how many grams of my mercury 1 nitrate can be formed. So let's take a look at this and map it out. First, I'm going to have to go from volume to grams, and then grams to moles, then moles to moles, and moles to mass. Okay, so volume to grams, sorry, it's right on top there, grams to moles, moles to moles, moles to mass. So let's lay out our grid. And it's getting pretty repetitive. I think I'm going to skip this one just for the sake of time, and I think you'll have it by now. But just in case, I'm going to give you that answer. This is 17.5 liters of H2. Okay. If you're not getting that, you'll want to come see me or talk to me as soon as we get to class. I was afraid I'd tell you that, so let's get back to our original question. That was just a little deviation. So I've got that many milliliters of mercury. Now, my first step is to get rid of milliliters and go to mass, because I can't go from volume to moles of a liquid. There's not a conversion factor. You've got to go through mass. So I want to go milliliters to grams of my mercury. And what my density tells me here and here is there's 13.6 grams per 1 ml. That's what that slash means. And I just did it backwards. Must be getting tired. This will be the last one for y'all tonight, and I won't make so many mistakes. Let's flip-flop that. 13.6 grams per 1 ml. Now I want to go mass to moles. Mass to moles, you've got it, molar mass, 200.59 grams of mercury for every 1 mole of mercury. Now, grams cancel, milliliters cancel. I want to go moles to moles, so I want to eliminate moles of mercury and go moles of mercury nitrate, Hg2, NO3, 2. And there's a 2 in front of the mercury and a 1 in front of the mercury 2 nitrate. I'm right here on my map in case you've been lost. Okay? So this was step 1, and I did that here. This is step 2, and I did that here. And now this was step 3, and I did that here. Now we're on our last step. Moles to mass, use molar mass. So I'm going to get rid of moles, and I'm going to go to grams. It's 525.20 grams of my mercury 2 nitrate. So if you crank through all of that algebra, the answer to this one is 831 grams of mercury 1 nitrate. Not mercury 2, I might have misspoke earlier. That's mercury 1 nitrate. Sorry about that. All right, I'm going to call it a night, and you'll be able to as well. So until class time, this is signing off.